Okay. Hi, everybody. Is my mic working and everything? Perfect. Okay. Well, thanks, first of all, to the organizers of this conference. It's my first time here, to be honest, and I love it so far. So it is a great work that you put together. And thank you for welcoming me today here as the speaker. Yeah, I'm going to talk a little bit about something that I am very, very passionate about, namely the movement of infrastructure as code. And I would like to talk specifically about the possibilities that it brings to us as security professionals and the insights that it can provide, and sort of the way it is changing a little bit our deployment landscape. But let's start with an opening question. So what is everybody's understanding actually of infrastructure as code? Just no wrong answers, just, you know, anyone? Terraform. Okay, what else? Ansible. Okay, cool. So I hear tools. I hear tools, not principles, right? So, and that is like sort of the general understanding that I have that the world has about infrastructure as code. And I hope we can learn something a little bit today about that infrastructure as code does not necessarily mean infrastructure as code as many people understand it. Then we will talk a little bit about the gray areas that many infrastructure as code tools have, and infrastructure as code security approaches. Okay, so we're going to talk a little bit about the gray areas that are there. I mean, this movement exists since about 2015, you know, and it cannot catch up with decades full of IT experience as we actually have. And one of the things that I would like to also emphasize today is the absolute great chance that this gives us to perform some rigorous security testing. I know it is late in the afternoon, you know, and if you are forgetting everything else I'm saying today, those are like kind of the main points I would like you to take home from, okay? So, okay, let's talk a little bit about the evolution of infrastructure as code. So software deployments, as they are sometimes done still today and are done in the past, right? So everybody of us has worked at a place where there was a server set up by somebody who quit 10 years ago, and people say, don't touch, don't touch. We don't know what happened there, but this thing works, okay? So this is unfortunately something that almost cripples the ability to innovate, to move fast, to do anything, okay? So, and this is like sort of where the pain really comes from that led to the development of trying to codify a little bit of infrastructures. And in my perspective, and you know, I like that disclaimer of these are opinions of my own and nobody else's. So there's actually the two main things that led us today to enable us to do what we call now infrastructure as code, namely codifying anything we want to do in an infrastructure, having it inside a code base, having it part of the change management that is enabled, for example, by like, you know, Git or other change management systems of your choice. So two items are, first of all, cloud, right? So you don't need to go anymore to your IT department and say, I need a server in this rack in 2 weeks or something like this. You can just provision them. Although, you know, in principle, it's still the same. It's just more automated than it was before, okay? And all those actions happen through APIs. That means there is like less of the personal touch involved and less people involved. And so there's no physical machines on premises needed. And the other item that is very important is the containerization. So anybody who has written Docker files here? Okay. I knew this would be the majority. This is wonderful. So you have now truly reproducible environments. You literally write, I want to install this. I would like this operating system or this base image. And you go step by step by step. You basically create a documentation what is inside your container. Okay, so this is basically your new SBOM, or nowadays the term IBOM, infrastructure bill of materials, has sort of come out of this movement. Okay, and what you can do now, again, with this, and I cannot emphasize this enough, you track those changes that you do inside there with inside a code repository. Right? I remember when I first time used Docker and I had an intern, I asked them to write some Docker files. They were like, well, why am I not just spinning up a container and do the changes there? No, because the problem really then is then you lose the ability of immutability, and then you're back at sort of this case. Okay, so you don't want this. So now we actually have this ability to say, this is our infrastructure. This is how it was built. It doesn't matter what personnel changes we had in the last couple of years, we can do this. And those are the true changes or revolutions inside our technology space that enabled us to really codify what we're doing with our infrastructure, okay? So So now the question is, what are the new possibilities that this gives us? And now let's take like a 10,000 feet bird view on this, okay? So we can keep it inside a code base. And what is also important is we can move actually faster. We don't need to think anymore, oh, what happens if I do changes in this machine, or who did changes in this machine last time? We have actually a full sort of audit log of changes available to us and right in front of us. And previous speaker here was also the one who talked about moving fast and breaking things, right? I mean, to me, actually, there's also this perspective of if you are able as an organization to move fast, and do it not because you have to move fast because you need to get a project done, but because you are really confident that you can actually move fast. That is actually, to me, a biggest sign of security that you can have, because that enables you to do small changes fairly quickly. And we all know that fixing security holes are an accumulation of a lot of little tasks that you just have to do, certain settings you have to set and things like this. So we can now also, using this containerization thing, it enables us to create sort of a very, very prod-like environment on our local machine. So whatever you're doing with your containerization orchestration in prod, you can emulate sort of almost one-to-one with the Docker Compose locally. This means you will introduce less deployment bugs. You will create less issues once you put those things in, okay? And then we can also, given this, we can, of course, reap all the benefits of that code always had compared to infrastructure. So people can create pull requests, people can review them properly. So we have actually a possibility to bring this software stability. And I always like to use this example of blue screens. I mean, we all remember blue screens, right? So software used to be like very unstable until we actually did software development properly and had static analyzers look over our shoulders and things like this. We can actually reap all those benefits and apply them now to actually infrastructure. And as the last point, I mean, I know I keep repeating myself, the immutability of it is actually a concept that allows us to, actually have these very stable environments that we have a clear idea what is happening inside of. Okay. So now let's talk about the 37 flavors of IaC or more. So when I asked my initial question here, there was like Terraform, right? This is like an initial reaction that many people have, but there's different flavors of how to actually create your infrastructure. So first of all, there's some cloud native scripting possibilities. So there's from AWS, it has its CloudFormation. What is it called? Microsoft has its Azure Resource Manager. Google has its Google Cloud Deployment. And those are all usually YAMLs, or except Microsoft has this bicep format that I don't know. Did anybody actually ever write any bicep files? No, thank you. That's what I thought. Then there's, of course, those external frameworks that try to be like, okay, well, I mean, we are partially dealing with hybrid cloud. We're dealing with like sort of mixtures of everything. So then Terraform came around, or Pulumi, which directly is working like a code library that you can use inside your Java code or your C# code. Then there's Ansible, Chef, Puppet, and the list goes on and on and on, because there's a lot of those sort of tools that have spun up. But those are like, I would say, the most prominent ones that are out there, okay? So those are like frameworks that people are using for one reason or another. Okay, so now the other thing is that, and this is the other thing that I was kind of missing when I was asking the question, Kubernetes, where does this all fit in, right? So Kubernetes is a container orchestration tool/methodology, which allows you to basically create an environment of containers and give specific instructions how they interact with each other, almost like firewall rules. They can create a whole ecosystem of containers. And in a very minimal case, if you're using cloud plus Kubernetes, you can actually just tell your cloud provider, set me up with a Kubernetes cluster, and I take it from there, right? So your Terraform file might be very simple. So this is how Kubernetes fits in all of this thing. And one of the questions that very often come when it comes to infrastructure as code, and specifically the tools, what should my org use actually, right? So there's like, this is the overarching question, because there's just so much available. The space is very crowded. So of course, short answer is it depends, like it really depends on what you're doing. And the long answer is like, it's more like a journey. It's not like a destination. You should usually, if you are migrating towards it, you should do it step by step, from starting to containerization to moving everything into your code pipeline. Just as little decision guidelines, though, if you are using anything that is just cloud, you can go ahead, use the native apps, use the Terraform, use whichever one you would like, right? That is not a problem. If you're doing anything on premise or anything that is in a non-major cloud provider, okay, because many people are trying to use nowadays different cloud hosters and more simple providers in AWS, Azure for cost-effective reasons and things like this. Just use something like Ansible, which also has capabilities to set up machines directly and create certain playbooks. Okay, so those are like sort of the decision guidelines. Okay, so this hopefully answers or gives you a slight overview of the infrastructure as code world as it exists today. Any questions for now in between before I go to security? Yes. Oh, yes, of course. Oh, thank you. Thank you. This is a very good question. So, okay, say you have a server, right? And somebody in your team has, say, SSH access rights to it. And they exercise these rights. They do a change inside the server live, and you have no trail of it. You have no audit trail of it. You don't know what they did, but somehow it fixed your current problem. They were fighting a fire or something like this. This means at this point, this server/container is now tainted with something that you cannot really reproduce. Immutable means you do all the changes in the code and then deploy them over there, and then make sure once it is up there, nobody touches it, because then you are not losing your sort of audit trail or the way how you can then reproduce whatever has been done there before in order to get to a working state. Yeah. Yes, 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 and then that is sort of the goal of the whole premise of the infrastructure as code movement. Although in most places it's still the case that you spin something up and then people still do those games. This is what I'm describing is also more of an ideal scenario, how it should be done versus how it's actually still done. There's there's still a little bit of a gap. I hope that answered your question. Yes. Absolutely. Oh, absolutely, absolutely. This is definitely one of those things that. So, in case some people didn't hear this, it's like it reduces the amount of tools that you need to use or that your team needs to know, because you can go by the what is it called? By the things that your team already knows. Okay. As per the evolution of security testing with IaC. So now, okay, now that we've been talking a little bit about it, let's think about what if we do true IaC. And I'm not just talking about the resources that we acquire from our cloud provider. I'm also talking about the configurations inside containers. Let's say you spin up a container with a Postgres. You can actually keep that configuration file also inside your code repository. So that means you have a full visibility, what you have been configuring, what you have been doing out there. So there's an ability now to do actually what we call whitebox penetration testing. So assume now you have like this total overview of this is how my application is built and this is how my security goes. And this, say, it's like a little visual of like, okay, you have an idea that you have like a wall there, but there's like a little hole there. Let's make this like you have a SSO, but there you allow one path with basic auth or something like this that you allow in your infrastructure. You would actually see this, right? Because you can look inside the configuration files. You know how these things are configured. You can find the little tunnel that you allowed for certain special applications. All those things you would usually not be able to find with what we call the black box penetration testing. And I would always like to use the strategy video game example out of this. So this is all the good old Warcraft 2, right? Imagine you have like this map that is totally not explored, but you have only a limited amount of time, limited amount of resources, and you have to explore with whatever your little orc friends are knowing about, whatever you can attack. right? So you have no idea what is behind, but you try to gather and you try to fill out this map. So this is sort of a brute force approach. And this actually will lead you obviously to also some results and very common attack vectors, but it doesn't give you this very clean view of whatever is there. And now the question is, of course, why didn't we do this all the time? Well, in this traditional model, the, hey, this is the server, don't touch sort of scenario, right? Actually, to get to those configuration files, to find all the configs for your Postgres instances, for your web servers, it would require the IT team to actually SSH into a lot of servers, gather a lot of files from you. This was infeasible. This was actually simply not possible, although it would have been the cooler thing to do, of course, right? Given that we can now move all of this stuff into a code repository, you can literally copy it locally and run it, and then also do security scans on those configuration files locally, enables the feasibility of this approach, right? And yeah, and in the end, you also have, of course, since this is also a journey, let's say you have nowadays a cloud setup, but people didn't use necessarily Terraform or Ansible or whatnot to set it up. You can actually get nowadays also snapshots from your cloud and translate them into IaC and then do those configuration scans. And this is one of those things that I would like to communicate today. This is a great opportunity to have a full overview on what you're doing and where your risks are openly in front of you for analyzing, either automatedly or via via manual review, right? So this is like sort of the what I think is the greatest revolution for from a perspective of security, which IaC provides. Okay, so now one thing I would like to add here is, unfortunately, right now we actually do have a little bit of a false sense of security when it comes to IaC and yeah, and its capabilities. So first of all, let me give you some examples. Ansible as an external framework compared to a cloud native one. If you have, who uses DynamoDB? Okay, one over there, two. So DynamoDB set up in AWS. If you do it via Ansible, in the documentation, you will not find a way to encrypt it at rest, although AWS has perfectly capability of doing this. So you have to make sure that you're actually studying the capabilities of your cloud provider, not of your tool. So this is like one of those things that are very important. And current IaC scanners, many of them, are not necessarily figuring out all those nuances, right? So most of them focus also just on Terraform and CloudFormation. So for example, if you use Kix out there, you would, and you look at the Ansible scanner, it actually only looks at AWS, Google Cloud, or Azure. If you use Ansible to do playbooks to install stuff on servers, you are actually absolutely not covered there. But you get this false sense of security. Okay, I have my IaC code scanned. So even, yeah, this also comes under the point that for those supported tools, those scanners are not complete. And the other thing that I would like to mention is, we should also not forget when we're talking about IaC, IaC is not just this top layer of Terraform or Kubernetes files. It is also what is inside the containers. As said, the web server configurations, the database configuration, the streaming server configurations, everything like this should be in your code base and also should be scanned. Okay, so and this is what mainly is ignored. And if you're looking at the term of container scanning as it is being used today by many providers out there, what they're doing is actually a CVE enumeration because they're looking at the software that is installed there, but not actually at how things are configured and if they are done right in there. If a MongoDB, for example, has its default non-authentication mechanism disabled, for example, right? So anyway, just to, because I'm almost out of time, let's talk about like how this sort of can change the future. This actually enables us to create this concept of a self-healing infrastructure. So as we have for code, we have a good way of sort of the process of creating and fixing bugs and iterating over the code base. We can now do the same thing over infrastructure. And open source container orchestration contains enterprise level mechanisms such as failover and other things that usually people would do in a very makeshift and manual way in the classical scenario. Scanners can reveal then if you use those mechanisms or not, and pre-deployment testing, like in the software world, will make infrastructure more stable. So that's sort of the goal that we're having with this, okay? So then the other thing that this would enable is if you're looking through compliance frameworks, and yes, no, I'm not a CPA, but I've read the trust services criteria of SOC or HIPAA or whatnot. If you're looking over this, a lot of things is actually hidden inside configurations. You cannot necessarily attest that something is done right, but you can at least say something is done wrong if you can find in configuration files a lack of authentication mechanisms or some encryption at rest or encryption in transit sort of parameters missing and things like this. And then you can have, obviously, with this infrastructure as code movement, the change management addressed. So this is actually something that we can almost put on autopilot in the future, at least the technical part, obviously not the HR things that SOC also encompasses and things like this. Okay, so now let's drive a little conclusion, and I stayed, I think, within my time frame. So IaC promises a shiny future. We are there, almost there, not yet. But just keep this all in mind. I mean, this is actually something that will enable us to do things very right, and even smaller organizations to use enterprise level mechanisms. Okay, so then be aware of the current limitations of IaC tools and scanners. You can, if you start the journey today, you can actually reap the rewards very quickly. And on our blog, we actually have a bunch of articles that provide you with a lot of examples of where things can go wrong with current IaC tools and how to scan things. And if you would like to see some example reports and some ways how to misconfigure certain services on your infrastructure, you can actually check it out on our portal with some example configurations that we provide there. Okay, other than that, thank you very much. Those are like my handles. And yeah, any questions? Okay. Yeah. Okay, well, that's of course a good, very good question. So I mean, the short, I mean, how I have done that in the past is like you focus on the functionality that the server needs to provide, right? So it gets certain calls from other external services, and you slowly take the functionality out of it, right? So you go function by function by function, and you keep it alive, but you get less requests in it. And once it is dead, you kill it. So this is sort of how I would go about it. Yeah. Configuration and then updating your existing IaC with all of the future deployments. So what you have just described should only be a breaking glass mechanism. Okay, so you were saying that somebody actually just goes in there, fixes something quickly because heck, something is going extremely wrong. So ideally, this shouldn't happen too often, right? But if you do this literally every step of the way, what are you doing? You're executing certain commands, right, on the command line. So you keep a track of those commands, and then you put them either into the Docker file or wherever you have it in order to do those specific fixes. Now it also always depends. So now actually I have to roll back a little bit there. It's like, is this a database problem? Is this a problem within that Linux system or things like this? So usually if you have, for example, a database problem, then and you have to basically manually go in and something goes wrong, you have to also look if you're applying database change mechanisms properly, like for example, Liquibase or something like this. So you have to make sure that every tool and every process that you use has some form of traceability, right? And as long as you have that, like this example that I said at first, copy those commands into the Docker file. That would only work if it's something on the operating system level or something like this. But make sure that even for your databases or any change that you're making, it has a certain sort of tracking mechanism, right? And that is sort of how you get around it. But you're right. This falls under this sort of gray area if you have something exotic going on that is not very standardized out there. Yeah. Yes.
So a lot of what you described here, it sounds like the same sort of techniques we would already be using to inspect software.
Yes.
And to your question, should we be alert anytime somebody begins saying something is software defined something, this could very well be IaC.
Absolutely. Absolutely.
So software defined networking.
Yeah.
Software defined radio.
Yes. I absolutely agree with this. So and it's like this sort of, and also all the problems that come with it, and also all the processes that you are usually working with if you're using software should be applied here. And that is like sort of the change of thinking that, you know, needs to sort of happen, because
but done properly, it's DevOps sprint, not a shipment from Cisco.
Yeah. Yes. That's also very fair. Yeah. Yeah.
You mentioned code scanners and other cloud tools such as BitPM, BWPP. How do you use those in conjunction with your IaC workflow?
So usually, okay, this is also a very good question. So how do you use code scanners today? I mean, it goes back to like, how do we do code? Well, you have a Jenkins, or you have a GitHub Actions, or Bitbucket pipelines, whatever you're using for your CI/CD pipeline, you have this sort of testing area, right? So, and in this exact same manner, you create a pull request, it automatically spins up one of those scanners. The scanner either gives you a green light or a red light, and then either you fix something or not, and then it goes over to manual review. But yes, so the principle should be the same as for code nowadays. I mean, if you're thinking about it, historically, when we wrote code, we would create it, code it, throw it over to QA. They would push some buttons in the hope to find something. And obviously, they always didn't find everything. And it came back. So the same we actually do sort of with infrastructure today, right? We put it on a test environment. The QA goes in, clicks around. Oh, seems all stable. Let's ship it. So, and this, obviously, we still need the QA, but you know, this assistance of additional tools that can actually automatically look inside of all of this is sort of the yeah. Yeah.
Just further to that point, though, a lot of the stuff in your pipeline today for your code is looking for things like vulnerable modules.
Yes.
I don't think that's going to happen as much here. You're going to be thinking more about tools that look like dynamic analysis and static analysis tools that look in detail at what you wrote.
Yes.
What you wrote, not what you called in, but what you wrote.
Yes, exactly. Exactly. Yeah. So this is basically what we're doing at our company. So yeah. Yeah. Oh yeah.
Okay. So the tool with which we
yeah.
But you know, to give me some deploy version for, say, if I'm setting up an infrastructure with code, I would need some sort of, you know, if I'm pulling things from online, it would need like a repository software. The software that needs to be something.
Yeah.
So what are tools used to manage?
Oh, those are many. So I mean, generally, I mean, so it really depends how you're doing it, right? So yeah, you need to have the repository ones, right? That are many of those are actually provided to you by the cloud providers directly. So you can actually look into those. Like, I don't want to now advertise many different ones, but yeah, if you want, you can come after the talk to me. I have a bunch of lists here right here.
Well, thank you so much, Albert.
Yeah.